We moved today from solving inequalities using addition and subtraction to solving inequalities with multiplication and division. We're going to start like we did the other day with testing the four properties of addition, subtraction, multiplication, and division with a true statement of 3 is less than 7. We said the other day that if we add the same thing to both sides, like 2, inequalities will hold true. So I have 5 is less than 9. That's still true. So I can add the same thing to both sides and still get a true inequality. If I subtract the same thing to both sides, let's subtract 2 to both sides. 3 minus 2, less than 7 minus 2. That's 1 is less than 5. That's true as well. So subtraction holds under inequalities as well. Let's take and multiply to both sides. If I take and multiply 2 to both sides, I have 3 times 2 is less than 7 times 2. And I get 6 is less than 14. So that seems to hold true as well. And let's try division just for kicks. We'll take 3 divided by 2, and that should be less than 7 divided by 2. This is 1.5. This is 3.5. And it appears that division holds true as well. However, let's do this. Let's take and multiply by, let's say -2 to both sides. We get -6 is less than -14. This is not true. And if we did the same thing on the other side, take 3 divided by -2, and say that's less than 7 divided by -2. We're saying that -1.5 is less than -3.5, which is not true as well. In fact, what's really happened is in each case, the inequality would have to switch directions in order to make the statement true. And that's actually the case. So we now have a rule that states when you multiply or divide both sides of an inequality by a negative number, you must flip the inequality sign or change the direction of it. So multiplication and division with positive numbers hold true under inequalities, but multiplication and division with negative numbers do not hold true with inequalities. So let's do a couple of problems. Here's a problem. We have to solve this. Divide both sides by 6. Now notice I'm dividing by a positive 6. So the inequality statement will hold true when I divide by a positive. There's my algebraic solution. Here's 4 on a number line. It's not including 4 in my solution, so I open circle going to the right. Notice, to get x by itself, I have to divide by a negative. If we divide by a negative, we must flip or reverse the inequality sign. So this goes from greater than or equal to less than or equal to. And that's x is less than or equal to -7. So if I put a number filling in my circle because it's less than or equal to, and moving to the left. If I pick any number to the left and plug it in to x, I'll get a true statement. Well, a number less than -7 is -10. Let's say I was to put -10 here. Then I have positive 80 is greater than 56, and that worked. If I was to pick a number like 0, because that's to the right, it shouldn't work. So put a number like 0 in here. 0 times -8 is 0. That's not greater than 50, so that wouldn't be true. So it appears that my answer checks out. Let's do another one. This time I have a fraction. And in this case, I want to get rid of the negative 4/7 multiple. So I have to multiply by the reciprocal, which is negative 7/4. Since I'm multiplying by a negative number, then I must turn the inequality sign around. So it goes from less than to greater than. And I have negative 35/12. It's my solution. If I put negative 35/12 on a number line, it's not including, so I open circle and I move to the right. So here we have a word problem, and it says Gil earns the following test scores on his first 3 tests. He has an 86, an 88, and a 78. And we want to know what is the lowest score that he can earn on the 4th to have an average of at least 83. So we want to be 83 or better. If we want to be 83 or better, we have to be greater than or equal to that. Now, if we take an average, we add all the numbers up and divide by the total number of numbers. We already have 3 tests, and we're going to take a 4th. So we have 86 plus 88 plus 78 plus whatever our unknown is. That's our 4th test. If I want an average, I divide that by the total number of tests, which is 4. To solve this, I can multiply both sides by 4 first. And since I'm multiplying by 4, we don't reverse the inequality. And 83 times 4 is 332. And that leaves me with 86 plus 88 plus 78 plus x is greater than or equal to 332. This gives me 252 plus x is greater than or equal to 332. I'm going to subtract 252 from both sides. And I have x is greater than a total of 80. So if I score 80 on that last test, I'll maintain an 83 average.